Okay, so can you guys still hear me back there? Coming off of a cold, so we'll see how my voice lasts. So in our center work, as we take the knowledge as imposed brought to us by the literature and heavily the kinds of speakers that we had thus far, we and then had to do lots of work. You know, we didn't say, oh, I've got an idea, let me test it out in an interesting place where I think it'll work. The curricula came to us, and then we just had to say, okay, what are all the things I can fix with this hammer in my hand? And hopefully there's lots of nails. So I think it's worth reflecting a little bit about the risk. Why might this not work? In the research literature and the research communities, there's this kind of tension about how do we even understand things? What should we care about? On the one side, caring about generalizability. Let's study it in the wild in the first place because then we know it applies in the wild. Or should we study it in the lab or in the controlled classroom setting where we kind of cherry pick the situation we're in, the kind of curricular element that's most likely to support that. But then we really know, with a capital K, that this is what led to change. So we get to do the random assignment. We get to remove other factors. So we got students who are at the right place to take this on. We've got teachers who are on board with what we're doing. And this is kind of a bit of a battle out in the research literature. And then another issue has to do with contextual interactions. Does what you learn in this setting apply even in these other settings? And people often raise this, and arguing against this idea that that's something you should even worry about is this idea that the things that you bring, the aptitudes, against the treatments, that they have an interaction, that different learners benefit from different treatments, as are formally called aptitude by treatment interactions. By and large, those are mostly based in folklore. There's way more people who think that's true than it's actually true. When you run the studies, it's very, very hard to find any empirical demonstrations of aptitude by treatment interactions. But we should mention you need lots of numbers to even be able to establish it. So it's a hard thing to go after because you got to have enough in all of the possible treatments by the different subgroups, and then enough of an N to detect subtle little shifts because you're usually looking for little things. And then it's kind of hard to interpret what about those different situations really is driving things. Is it really that the treatment is different or the way it was interpreted? There's kind of mess around that. So it's sort of one reason to say let's stop caring about that because it's probably not a thing. But then on the flip side, one could say way too much research is based on prepared learners, motivated learners, low context noise. That is to say, literally there aren't random people coming into the classroom disrupting announcements, would so-and-so please come to the front office every 2 minutes. How does anyone pay attention in those contexts? Okay, and if we think about sort of national educational policy, actually the weakest learners drive a lot of the policy. We don't, when we have the people who are at the 90% and then they go down to the 88%, or maybe they went up to the 92%, none of the real metrics are influenced by that. It's about the percent of kids who failed and the percent of kids who did not fail. It's that shift. So worrying about what moves the needle in that bottom set is really important. Okay, so these are motivate why we should worry about how this is going to play out. In addition to the big study that we'll talk about before, I want to tell you about a meta-analysis that we did. So that's you look across all the published studies in a topic and look for patterns. How good is the evidence across all the things you can find? And this actually just came out a few weeks ago. So hot off the presses, literally. And I should point to Lou Alfieri, who's the lead author, and then Tim Noakes-Malik, who was involved in the center work at the beginning. Okay, so we found 57 studies over 27 years. This is over 3,000 learners and lots of particular tests within those studies. And this is all sorts of different ages, content areas. Is contrasting comparison really such a big thing? And it turns out it's got a pretty good effect size across all of those studies. And another thing one worries about is the file drawer effect. Maybe they only published the ones where they got an effect, and either Dedry just buried all the oopses. She's got a very large closet of all of the ones that didn't work, or there were all these mean editors who said, if it doesn't have an effect, I don't want to publish it because that's just boring. So we can compute how many skeletons must there be in the closet such that there's not really a thing, so that it's just a fluke, the few flukes got published. And the answer is almost 3,000 skeletons need to be in that closet for us to think contrasting case is not a thing. And so therefore, it seems implausible to us that they would have that many skeletons in their closet. So I think we've got some pretty good evidence that contrasting cases really is a thing as a general technique. We looked at moderators, what influences how effective comparison is. Turns out there's a whole bunch of things that don't matter. So age doesn't matter. Contrasting cases, on average, is just as effective for children as adolescents as for adults. Overall experience in the domain, this is a point that Dan made. It's as useful for novices as those who have some familiarity with the domain or not expert, and for experts. Everybody benefits. The effect sizes are just as large in the classroom as they are in the laboratory, which I think is particularly important here. And then how much you kind of have the big Monty Python hand pointing, pay attention here, turns out not to matter so much. You could have a light nudge or really point here. Either way, that also works. There were, however, some things that did matter. For example, do you have learners pay attention to the similarities? Tell me what's the same. Do you have them pay attention to differences? Or do you have them do both similarities and differences, and you get the best effects if you say just similarities? So this is where the goal is to learn about the thing that is common. So I want to make that point here. If your goal was to learn about what is different, then the story is, you won't get a negative effect for pointing out differences. Then there is whether you should say what they're really looking for. Should you let them see it and then tell them to them? Should you so it's say it first, then let them see it, or let them see it, then say it, or don't say, just let them see it or not. It turns out, consistent with what Dan had said, putting the principle after they see it. So don't shortcut the learning by saying, okay, this is what I'm going to tell you, now go look. Rather, look, and now I'll point out what I really wanted you to pay attention to, that is much more powerful in effect, and that filling in what you should have seen is important above and beyond just trusting that they got it from the comparison. And then you might wonder about what kinds of things one would learn. Science actually has a mixture of kinds of contents. So we've got big conceptual ideas. I've got a goofy little icon here. Hopefully you figure out what concept I'm trying to show there. I couldn't quite come up with a little graphic for all the abstract ideas we have in science that wouldn't then make you think it was a picture. There's lots of procedures we're trying to teach people. First do this, then do this other thing. And then there are fundamentally some perceptual things. Learn how to see what these sorts of things really are. And Edry had some nice examples of bone structure that have that character. And it turns out the perceptual areas show the biggest effects. And Dan's story about the two functions, the learning to see and then the induction, I think, might give us some ideas about why it's most powerful in perception, but it's powerful across the board. There's tons of studies showing on very procedural things that you get some nice effects there. Okay, so from that, like we were well positioned to really dig in, and I think in our center's work, the biggest change we made to the curricula was around the use of contrasting cases. The most days of instruction, the most minutes of instruction were nudged with this. Okay, so how did we approach this? We had two very different curricula that we took on. One was this textbook case. Every day we read. There's an optional hands-on activity that you might get to, but oops, we never got to that. And then we took a very opposite extreme case that's widely in use, a very hands-on. We do experiments every single day, or very rarely we'll read something, and then I might tell you what you should have seen, maybe, but I might not, because it's up to you to figure that out. And so in those two very different situations, we came in and said, how can we apply contrasting cases? So the first thing we do is we analyze the unit. In either case, what really are the big ideas of this? Because you would have thought they'd make that very salient. No, it's not all that salient as to what the really big idea is. And then what are the misconceptions? So we chose to put the contrasting cases around the big ideas that were likely the hardest for the students to learn. So we sort of pushed hardest in those places. Here's an example of a kind of thing that we did. We wanted them to see what is in common across different kinds of animals. So we took bizarrely different kinds of animals, like what does a T-Rex, a bonobo chimp, and a barnacle all have in common? And we gave them little cards that had some properties, and they had to figure out what's that shared set. And we really, and sometimes we gave them Venn diagrams, sometimes they filled it out in tables. We had a variety of approaches to support this, and especially important, fill out what do they all have in common. If you need to obsess and write some differences, okay, but pay attention to the similarities. And they did that first in a section. And then if it was a textbook, then they did the readings. So contrasting cases, then do the reading. However, they would do the reading either individually or as read out loud in the class, or sort of whatever classroom policy is. Or in the case of the hands-on, then they would go into their experiments. They would measure some things. They would smell some things. They would, look at some things as they would do. So it was contrasting cases and then read or experiment, discover that way. And as one last point, we discovered that in some instances, the goal really is to show differences. So how are these big categories different from each other? And in those situations, we had them start with, after they learned what was the core feature of a particular subcategory, so like all animals or all plants, we then had them, after they learned those pieces, do a contrasting thing across those bigger categories to emphasize then how are those categories different from each other. So this is just to come back to that point that when your goals are differences, then obviously it's good to attend to those differences. Okay, so let me bring the gang back up front and we'll have some general questions for 5 minutes, and then I'll let your stomachs take over and lead you in the appropriate directions.